Hello, this is your Ghana mathematics teacher. Welcome to Mathematics Gymnasium. Today we are going to discuss a concept that is not popular yet very relevant. And when I say that, I'm talking about SURDS. Depending on different authors, some will call it radicals. But then in the course of the discussion, you'll find out what that is. The expression we have on the board is a SURD, an expression in SURD. That is because we all know that 50 is not a perfect square. So in essence, any number that is not a perfect square that finds itself under the square root is a SURD. It's as simple as that. These are basically the rules of SURD. When we get to rationalization, we'll take it off from there. So, in actual sense, this is what the rules mean. If you have two expressions that are in SURD form and they have the same terms under the root, but the terms happen not to be perfect square, in the first place, that's what makes it a SURD in the first place. So you add the coefficients and that produces something like this. If you have to subtract one from the other, you have something like this. Now, if you have two items under the root that are multiplying each other, you can as well split them, each bearing its own radical. Now, the same applies to division. That's, for instance, if you have 1 over 9 under the root, it's as good as 1 over root 1 over root 9, and that is going to give us 1 over 3. This is if you have the same items multiplying each other both under the root, then you have that item up. Standing on its own. Say for instance, if we have 2, root 2 times root 2 is equal to 2. Root 4 times root 4 is equal to 4. Root 4 is 2, root 4 is 2. 2 times 2 is going to be 4. So those are some of the applications. Now, the manifestation of problems involving SURDS may take the following forms. I like to relate concepts to one another. In case of fraction, one can ordinarily be given a single fraction, say 27 over 45, and one will be told to simplify. One only identifies the highest common factor between them and simplify. The same thing is applicable to SURD. As we have in this case, one may be given something like root 50 and will be told to simplify. So, when given something like this, the first thing to look out for is the number under consideration will be expressed as product of its factors. Now it depends on how familiar one is with multiplication of numbers greater than 12 that everyone is familiar with. So if I'm given something like this, it implies root 25 times 2. Now recalling from one of the multiplication law that root a times b is equal to root a times root b. So it implies root 25 times root 2. Root 25 being a perfect square, we now have it to be 5 times root 2. Therefore, root 50 is characteristically equivalent to 5 root 2. And this is what it means when one is told to simplify such an expression as this. So, here is another example. One may be told to simplify stuff like this: root 50 plus root 72. The same thing that I did with the root 50 is what I'm going to do as well, with the root 72. Now, we have root 50 plus root 72, and we're told to simplify. The first thing we are going to do is to simplify root 50, and we express it as 25 times 2. 25 being a perfect square and 2 being an imperfect square. We do the same thing for 72. 36 being a perfect square and 2 also not being a perfect square. So we apply the multiplication law to simplify this, and that gives, we split this into 2, and we have root 25 times root 2. 25 being a perfect square leaves us with 5 times root 2, plus 36 being a perfect square leaves us with 6 times root 2. Now we have 5 root 2 plus 6 root 2. Then we have to make reference back to the addition law. And when we have two surds with different coefficients but the same stuff under the root, we simply add the coefficients, and that is what we did here. 5 root 2 plus 6 root 2 will now leave us with 11 root 2. So that is the simplified version of root 50 plus root 72. Here's another example. We will be given something like this: 8 root 75 plus 2 root 3 minus 5 root 48, and we'll be told to simplify. So, given 8 root 75 plus 2 root 3 minus 5 root 48. The first thing to look out for is, do we have any perfect square, a factor of this that is a perfect square? The answer is yes. So it implies 8 into root 25 times 3 plus 2 root 3 minus 5 into root 16 times 3. So going by our multiplication law, we now have it to be 8 into root 25 times root 3, then plus 2 root 3 minus 5 into root 16 times root 3. From what we have now, 25 is a perfect square, so we are going to have 8 times 5, the square root of 25 is 5, then times root 3 plus 2 root 3 minus 5 times 16 is a perfect square, which is the square root being 4, then times root 3. Everything now is in root 3, so we have it to be 40 root 3 plus 2 root 3 minus 20 root 3. So by reason of our subtraction law, we can, of course, addition comes before subtraction in the order of operation. So we still put it as 42 root 3 minus 20 root 3. So our final answer would be 42 minus 20 root 3, leaving us with 22 root 3. Now this is our final answer. Suppose we are told to write it in the form x root y, but if we are told to express it as a single surd of the form root x alone, then it means we are going to square this. If we square 22, it's going to give us 400. 1452. If at all we are going to express it as a single surd. So that is what we do. There are instances also where we have to express everything as product of prime factors. Then we begin to pair every of the prime factors that appears up to twice or 4 times to get the perfect squares out, and in the long run we simplify it. So these are some of the things that we do. This, like I said earlier, is not popular, but it is very relevant. There's what we call rationalization, and there's what we call rational numbers. Generally, rational numbers are numbers that can be expressed as ratios of two integers. Say for instance, 25 can be expressed as 50/2. It can be expressed as 100/4. It can be expressed as 25/1. No confusion. 2.5 can be expressed as 25/10 or 5/2. Any number that can be expressed as ratio of two integers being whole numbers, are said to be rational. However, surds or radicals are irrational numbers. Reason being that they cannot be expressed as ratios of two integers. Like I tell whoever cares to listen, if you have a calculator and you punch √2, the degree of accuracy of your calculator will be exhausted. And yet, if you write it out and punch it directly, it will give you something that will either be slightly greater or slightly lower, such that you will approximate. The implication is that it is apparently not rational. So every number that is not a perfect square that finds itself under the root is an irrational number. Now, if for any reason we have a surd as a denominator, the number apparently is going to be an irrational expression. So it has to be rationalized, and I'll show you how that is done. If we have something like this, say we have 2√5/7. This cannot stand. That is because it is not permitted under this concept and every other concept as far as mathematics is concerned, except when the problem under consideration is an objective test. For want of time, the examiner may decide to leave it like that. Else, on rare occasions, will you have the final answer with a denominator that is a surd, because it has to be rationalized. And how do we do that? For a single surd in its simplest form like this, we simply rationalize by multiplying both the numerator and the denominator by the denominator. How do I mean? The denominator originally is √7. So we multiply both the numerator, which is 2√5, by √7, and the denominator also by √7. And if you check it, you find out that √7/√7 is as good as 1. So even if you multiply 1 by this, it's as good as having the same stuff. So the value will still remain the same, but the presentation will be slightly different, and it will turn out to be an acceptable version of it. So considering our multiplication rule, if you have this and this, we now have it to be 2 into √5 times 7 all over. Don't forget that all over 7. Don't forget that √a times √a is equal to a. So √7 times √7 is equal to 7. So we are now going to have it as 2√35 all over 7. So this 7 now can be shifted to this side. So we now have 2/7 as the coefficient of √35. 35 not having any perfect square factor will remain like that. So it's either you have it as 2√35/7 or 2/7 you still have the same thing. So this is what we do to rationalize a surd in this form. Must it, or is it always going to appear like this? The answer is no. sorts are said to be conjugates when their product produce a rational number or an integer, as the case may be. I give a few examples. Say this is a compound surd expression, and the other one the only thing that will be different will be the sign in between. These are conjugate surds. So the product of these two will produce an integer, and that's what made them conjugate. Just like multiplicative inverses in fractions or normal integer. Multiplicative inverses are two terms that multiply each other to produce one. In case of surd, two surds are conjugate when their product is no longer a surd but an integer. Now let's expand this out. The difference, what makes the conjugate is if this is positive, this one will be negative, but the terms will be the same. And that is how to identify the conjugate of a surd. The application I will do almost immediately. But in the first place, let's multiply this out. Suppose we have this, we now have, and from our knowledge of expansion, this will multiply this to give us 4, plus this will multiply this, this is going to be negative 2 root 5. This positive 5 root 5 will multiply this to give us positive 2 root 5. This positive root 5 and this positive root 5. Don't forget, this negative root 5. Don't forget that root a times root a is equal to a. But because this is negative and this is positive, we will now have this to be negative 5. So we are now going to have 4. This minus 2 root 5 plus 2 root 5 cancel out. So we now have 4 minus 5, and that leaves us with negative 1, which is a rational number, because negative 1 over 1 is rational. Negative 10 over 10 is negative 1, which is still rational. So this now confirms that these two surds are conjugates. Why do we need to recognize what the conjugate of a surd is? We can have instances where the denominator, like we had in the previous example, will not only be a simple surd but a compound surd, like this or this. So when we want to rationalize, we are not going to just write root 5, but we are going to write the whole of this, because this is the denominator. I will simplify one example right away. Say for instance, we are told to simplify this. This is what we are going to do. Whatever made any part of the denominator to be a surd is an indication that we have to rationalize. But the denominator in this case is not just a simple surd, but a compound one, so to speak. So in that case, we will have to rationalize. Usually this pair of brackets will be put to show that they are together. This is addition. Now, it implies, if you like to state that you are rationalizing, even if you do not state it, the examiner understands that you are rationalizing. It implies root 6 over 3 plus root 2. Now times the conjugate of this is now going to be 3 minus root 2 all over 3 minus root 2. So when we expand, we are now going to have 3 root 6 minus root, because this is going to multiply each of the terms here. So when this multiplies this, it gives us 3 root 6, and when this multiplies this, it gives us root if you like, you split this up. 6 times 2 all over. Now this multiplies this to give us 9 minus 3 root 2 plus this times this 3 root 2, then minus 2, because this positive root 2 times this negative root 2 will become 2, but because of this negative, the negative will stay. So we now have this to be this now becomes 3 root 6 minus root 12 all over. These two cancel out, so we are now left with 9 minus 2 all over 7. At this point, this 12 can further be simplified because 2 or 4 is a perfect square. So we now do 3 root 6 minus root 4 times root 3, then all over of this is 2. So we're now going to have 3 root 6 minus 2 root 3 all over 7. Okay, ladies and gentlemen, this is how far we are going to go on this discussion. However, you can subscribe to the channel and comment. Feel free to send questions and you can be rest assured that it will be addressed and will be forwarded back to you. Thank you and have a nice day. God bless Nigeria.